Hello students, I am Vikrant Sharma here. I am clearing your doubts, your concept regarding this shear force and bending moment and shear force and bending moment diagram. So I will start from the basic. Here you can see what is the shear force and bending moment. So shear force and bending moment are internal forces. Okay, shear force and bending moment, they are internal forces induced within beam because of this external loading. So as you can see in this figure 3.1 a, here there is one cantilever beam and this end is A, which is fixed support, and this is P, which is point load acting at this end. So due to this external loading P, some internal forces will develop inside this beam over this length L. So that internal forces, we call this as shear force and bending moment. So how to determine that shear force and bending moment? So let's first understand. We first draw the free body diagram of this, and the free body diagram is shown in this figure 3.1b. So we replace this fixed support at A by three reaction. One is AX, AY, and this moment reaction CA. And we make one cut at cross section C. So let's say somewhere here is point C, and we make this cut, and we have drawn the left side of this C in this figure 3.1b, and the right part of this beam towards this C is shown in figure 3.1c. Now at this cutting point C, you can see on this figure 3.1b that there is one vertical force V. This vertical force V is induced and the moment M is induced. Now this vertical force V and M, V is known as shear force, M is known as bending moment. So this shear force and bending moment are induced at this point C just to balance the left part of this beam in equilibrium. And in the same way, the shear force and bending moment in figure 3.1c induced here just to balance the right part of this beam in equilibrium. Okay, so this shear force and bending moment are forces induced inside the beam when this beam is subjected to external loading, and they try to keep that beam in equilibrium. They resist against that deformation. So if you see the sign convention, okay, the sign convention, if you see in this sign convention, what sign convention we follow when we show the shear force and bending moment? Let's understand this. See this sign convention. For shear force, the direction of the shear force and bending moment, note here, the direction of shear force and bending moment shown in figure 3.1b and figure 3.1c are established positive direction of this quantity. So as shown in this figure 3.1b, see in this figure 3.1b, the shear force is positive. This shear force which is acting downward is positive. So when we consider positive shear force, when the shear force tend to rotate the beam in clockwise direction. So if I make this beam fix at end A here, and if imagine that the shear force rotate this beam, so how that shear force rotate the beam? Clockwise direction. So we consider that shear force as positive. Similarly, in this figure 3.1c, the shear force acting upward is positive. How it is positive? Note here, if the shear force rotate the right part of this beam, that shear force rotate that right part in clockwise direction. So it is positive. So that is the positive shear force. So note here, a positive shear force tend to rotate beam elements clockwise. Okay. Similarly, this bending moment. This bending moment is positive. Note here, this bending moment is positive in figure 3.1b when this bending moment bend beam elements concave upward. So see that this bending moment is acting anti-clockwise, so that make this beam rotate upward. Okay, so it is positive. Similarly, note here, this M is also rotate this beam upward. So a positive bending moment tend to bend beam elements concave upward. That is a smiling beam. Means when that beam when the bending moment bend the beam like this, we can call this as smiling beam. How it is smiling? See, this is the bending moment on this side, and this is the bending moment on this side, right? So on the left of this beam it is clockwise, on the right of this beam it is anti-clockwise. So that you can note here, on the left of beam that bending moment is like this clockwise, and on the right of beam this is anti-clockwise. So this is some of the concept of this beam. Then shear force and bending moment diagram. The shear force and bending moment diagram. The shear force and bending moment diagram are plots of V shear force and M bending moment as function of position x. So over any distance x from any fixed end, we plot a graph. We call this graph as shear force and bending moment diagram. This diagram helps us understand how the shear force and bending moment change throughout a beam and show location where these values are maximum and minimum. So through example we understand few things on the shear force and bending moment diagram in next lecture.